Hello, welcome to Astronautics for Exploit. This is Dr. Anishola Ogundele. Space spin-offs, the products enhancing the humanity lives and contributing to the evolution of global economy. The focus points are space spin-offs and examples of space spin-offs. Space spin-offs, commercial products and services developed based on technologies that were initially designed and developed for space exploration, are aiming to enhance humanity's lives and contributing immensely to the evolution of global economy. Robert Ealing, a science fiction author, aeronautical engineer, and naval officer, who is also known as the Dean of Science Fiction Writers, in his writings emphasized scientific accuracy in his fiction and was thus a pioneer of the subgenre of art science fiction. His published works, both fiction and non-fiction, express admiration for competence and emphasize the value of critical thinking. While appearing before Congress in 1979, Robert Ealing aimed to bring awareness to the NASA spin-off concepts. In his submission, he stated that NASA spin-off technologies made it possible for him to undergo vascular bypass operation surgery to correct a blocked artery. Furthermore, he stated that the spin-offs that made his surgery possible were only a few from several NASA spin-offs from space development. Several space spin-offs on Earth and medicine, transportation, public safety, consumer, home and recreation, and a host of others have emanated from space exploration activities. Examples of space spin-offs are infrared ear thermometer, ventricular assist devices, and a host of others. Space spin-offs are technologies developed for space exploration that have found beneficial applications on the Earth. They are commercial products and services which have been developed with the help of NASA through research and development contracts, such as small business innovation research. NASA's collaborative invention with tool company Black Decker is shown in this picture. Examples of space spin-offs are as follows: aircraft anti-icing systems, scratch-resistant lenses, lighter, more durable brakes, cell phone cameras, memory foam, medical devices, computer mouse, light emitting diode lighting, global positioning system, water filters, and smoke detectors. Aircraft anti-icing systems. In aeronautics, ice protection systems keep atmospheric moisture from accumulating on aircraft surfaces, such as wings, propellers, rotor blades. Aircraft anti-icing and de-icing system is shown in this picture. De-icing or ice protection system prevents formation of ice and enables aircraft to shed the ice before it becomes dangerous. Scratch-resistant lenses act as a protective barrier, making lenses less susceptible to damage from everyday wear and tear. NASA's research into protecting space equipment from scratches, particularly amid fisters, led to the development of scratch-resistant lenses, which is now commonly used in glasses, sunglasses, and eyewear. A sunglasses manufacturer called Foster Grant first licensed this technology for scratch-resistant lenses. An astronaut with scratch-resistant lenses is illustrated in this picture. Cell phone camera is another spin-off. The cell phone camera in use today is a space spin-off, especially from NASA. A key component, the CMOS image sensor, was developed by NASA's Jet Propulsion Lab engineer Eric Voson in the 1990s in order to create smaller, more efficient cameras for spacecraft. The technology has become ubiquitous in digital imaging. Cell phone cameras, one of the spin-offs of NASA technology, is shown in this picture. Lighter, more durable brakes. NASA's groundbreaking expertise in reducing mass for spacecraft has led to advancement in automotive industry. Licensed NASA patented technology to develop an innovative brake rotor design. Current brake system technology cool disc brakes with air pulled from inside the vehicle is shown in this picture. Water filters. NASA's research into spacecraft filtration systems led to the development of advanced water filtration technologies used in various homes. Water replenishment. In space, water replenishment is a costly endeavor, and engineers are working on ways to make the process more efficient. A complex system of devices intended to sustain the astronauts living on the ISS and in the future sustain those blasted. The Discovery Model Unit pictured here has been deployed to rare areas around the world. Water recovery system on International Space Station make use of the available resources by turning wastewater from respiration, sweat, and urine into drinkable water. Amintine Substrand, designer of the life support system for the spaceships, developed the water processor assembly. Close-up view of the water recovery system is shown in this picture. Global Positioning System is a satellite-based navigation system which uses a constellation of satellites to provide precise location and time information to users. Initially, it was designed for tracking military assets. GPS technology is now used for navigation, mapping, and a variety of other applications. Satellite navigation GPS system is shown in this picture. Memory foam. NASA needed a material to cushion astronauts during extreme G-forces, and in 1966 they funded a project to develop a temperature-sensitive viscoelastic polymer. It was first created in 1966. They developed a foam that could cushion an impact collision. Then the foam has been adapted for use on the Earth. The picture here illustrates memory foam created by NASA. Medical devices. Space-related technologies have led to numerous medical device advancements, which include artificial heart defibrillators, insulin pumps, and infrared ear thermometers. Infrared thermometers developed from technology used in remote sensing satellites provide rapid and accurate temperature readings. An artist's rendition of an asteroid gathering samples on the surface of Mars is illustrated in this picture. Ventricular assist devices. The micromer, the big part uses technology similar to the turbo pumps used in space shuttle engines. Advances in microelectronics originally developed for space missions contributed immensely to the development of sophisticated cochlear implants. NASA astronauts on the treadmill is shown in this picture. Smoke detectors. NASA's research on fire safety in spacecraft led to the development of smoke detectors that utilize a dual-chamber design. The technology improved the reliability and sensitivity of smoke detection system. Illustration of smoke detector is shown in this picture. Computer mouse and microchip technology. Smithsonian National Air and Space Mission credits NASA's work in space as a catalyst for the invention of the computer mouse. NASA's Jet Propulsion Laboratory developed advanced microchip for use in spacecraft. Illustration of computer mouse is shown in this picture. Light emitting dart lighting. NASA's research into energy efficient lighting for space missions led to the development of LEDs. LED lighting, initially developed for space-based plant growth experiments, is now used in hydroponic systems. Commercial crew vehicle, such as the mock-up of Boeing 100, is shown in this picture. For more information, contact Astronautics for Exploits. You've been listening to Space Spin-Offs, the products enhancing humanity's lives and contributing to the evolution of global economy by Dr. Ayenshola Ogundele, with the focus point, space spin-offs, and examples of space spin-offs. Thank you.